Okay, question 7. Now let's take a look at question 7. First part, I call it A. Prove that the shortest distance from the origin to the plane is given by this. This actually has been shown in the lecture notes, but never mind, we'll do it again. The shortest distance from the origin to a plane which has this equation equals to D. Now example, you see question 4, you have this kind of plane, right? Example, this is just example. For illustration, we are not going to use these numbers, but I'm just saying this is a general form, this is an example. So you basically want this distance, right? And you know the normal vector is like that. How do you find the shortest distance? Shortest distance from the origin, in this case here, from the origin to the plane. How do we usually do it? We will find one point on the plane, let's call it A, yes, and I'll take OA. Project into n hat. Okay, project onto n hat. This is a projection formula, you must know this. Okay, done. But then we eventually want it to be shown that it will be like this. Yes? What is n hat? N hat is n over magnitude n. Yes? Not quite easy. Then the next part is the crucial step. What is OA dot n? Now recall here, equation of a plane, what is R? R is the position vector of any point on the plane. So you take the position vector of any point on the plane, you dot this, it will surely be equal to negative 1 for this plane. So I take OA dot n, it will surely be equal to D. Correct? Since A lies in the plane. So therefore this is just D over magnitude. Because OA numerator dot n is just D. Then what is it eventually? Therefore it is just mod D over, because magnitude of the vector n is already positive, don't need double modulus. Got it? Good. Next part. Given that another plane r dot m equals to c for a given unit vector, m, keyword unit vector, and a positive constant c. State what c represents. Now, you've got to suspect it's got to do with the earlier part. It all builds up. So, can I then say that using this result, with this like that, the shortest distance from O to the plane P is what? It's actually mod C over mod M. Where C is a number, you will see how I write this. This C is a number, M is a vector, because M is the normal vector. So this is, C is a positive number, so no point taking mod of C. M is a unit vector, so magnitude of M is just 1. So we better justify, we say since C is positive and M is a unit vector. So what does C represent? Just answer the question. C represents the shortest distance from O to the plane P. Done. Okay, last part. Another plane Q has this formula. Another plane Q has this formula. Find the distance between P and Q. Now, that is it's really very similar. I give you an example. This is not part of solution. I better draw it right here. Here. Not the solution. Imagine I have a vector like this. I have a plane, 0, 0, 1 equals to 10. This P1, okay? Dot 0, 0, 1 equals to minus 10, P2. Okay? Now, this number is the same. Okay? And this is a unit vector. This is a unit vector. Can I safely say that the distance between origin and P1, this one is 10, and the distance between origin and P2 is also 10? Agree? Yes, you use the result in the first part of the question. Yes, magnitude of this divided by magnitude of this is just 1, so 10. But are they the same plane? No, because why are they not the same plane? Because 0, 0, 10 lies on the plane, but 0, 0 plane, 10 does not lie on this plane. Of course. So they don't share any common point at all. I repeat, they do not share any common point at all. And yet, the distance from the origin to the two parallel plane, now look at camera head now, from a two parallel plane, okay, distance between the origin and the plane, P1 is 10, distance between origin and the P2 is also 10, and they have the same normal, and they're parallel. How can it be? There is only one possibility. The possibility goes like this. This is plane 1. The distance from the origin, this is plane 1. And plane 2 is on the opposite side of the origin. This one is another 10. Clear enough? There's only one case like that. Got it? Yes? So, now I will try and explain this. You have R dot M equals to C. This is what we call P. You got Q, which is R dot M equals to minus C. First observation, both planes are C units away from origin. And P and Q are parallel. Correct? They are parallel and C units away. And, okay, and they are on the opposite sides. P and Q are on opposite sides of the origin. So there's only one case. This is P and this is O and this is Q and this is another C. So therefore, the distance between P and Q is 2C. That's that. All okay? Good. Thanks.